All right. Hi everyone. My name is Ayodeji or Lord Sarcastic, and it's been a while since we had a meeting. I think more than a month now, about 2 months actually. But it's actually nice to have our first meeting, and it's a very good one. I'm actually excited for this one. We'll be having Habeeb talk about ML systems fail. I will not go much. I won't say much about this topic. I guess you will introduce because I don't know anything about it. Uh, so I guess that's it. It's nice to have you guys here. I'll be handing over to him. He will introduce himself. So far that I know, he's a machine learning guy. He writes a lot. You can check out his blog on Medium. I'm sure he will introduce more about himself. But I'll be handing things over to him. So yeah, Habib, aka Hacks.
Yeah, thank you. Good evening, everyone. That's if it's evening where you are, but I think it's evening for almost all of us here. So my name is Habeeb Shokweju, and this talk is supposed to be ML Systems Fail. It's supposed to be like a series where we just go through this first part, and this first part is probably the one that's most surface level, based on the fact that it's probably the one other people will be able to relate to quite easily. But the point here is to just take a look at how you get to make use of machine learning systems, say from the point of a product developer or a ML person or data scientist, and how you can get to work around machine learning mistakes, because machine learning systems will always make mistakes. That's kind of something people kind of struggle with understanding. It's a bit different from regular uh, code where you write this function, it takes in an input, and you are always sure that it will give the same outputs, and you have a limited set of inputs that it can possibly take. But with ML systems, you expect it to take a wide range of outputs. Say, for example, yes, you want to classify a picture. When you have an ML model, you really cannot say for sure that this is what the picture it's going to get will look like. It's almost limitless. Hence, machine learning systems are supposed to be expected to make mistakes, which kind of makes me cringe sometimes because it sucks. Like, I really don't want to accept the imperfections, and I want to see it work every time. Say, for example, it's a big company, you're serving 20,000 people, and just a trivial example here, it works 95% of the time. What happens to the remaining 5% of the people? What do you do in that case? Because you really cannot get a system that works 100%. So it's good to have that mindset of acknowledging that these systems will fail. So what do you do when they fail? And how do you manage those mistakes at inference time? Good. I hope that gives a good context on what the talk is about. And basically what inference means is making a prediction. So you give your inputs to your model and you get your results. That act of getting the results is basically what inference means, just getting your predictions. Okay, now that we have the context, which is probably the most important thing, let's go to me. My name is Habeeb Shokweju. Currently working as a research engineer in machine learning at Thomson Reuters Labs, and I'm interested in building information retrieval and machine learning systems. When I'm not writing code or reading books, I'm probably cooking or doing judo or having conversations with my friends. So that's about it for me. Then for you, I have no idea. I had no idea who and who was going to be on the call. So my assumptions were you could either be a software engineer, you could be a product owner, a product manager, a data scientist, a data enthusiast. So I'd like you to just quickly say in the chat section which of these you fall under. So I think that would be great to know. So if you're a software engineer, I would like to know if you're a product owner, a product manager, if you're a data scientist, if you're an AI enthusiast. You could just say that in the chats. Yeah. Everyone is saying intern. Why are people saying intern? Looking for bread. Okay, looks like it's more of software engineers on the call, and I really can't see anyone who's a data scientist. So I think that that kind of works as well. Now that that's good to know, we could just proceed. A disclaimer: I am not an expert. So while I've been working on ML stuff for a couple of years, I'm still far from what you'd want to call an expert. And in days like this, where everyone is a chat GPT expert and a cryptocurrency expert, I don't think I want to have that tag. So now that that disclaimer is out of the way, let's see. Machine learning systems, it's there's this dichotomy of it being both a blessing and a curse. I'm taking a look at this from three perspectives. The fact that explicit logic is not needed to build machine learning systems. It can tackle a wide range of inputs, and it's a black box. So what do I mean by this? By me saying explicit logic is not required, it means when you are building a model, unlike the situation where, say, you are building a front-end interface where you kind of type you kind of type in the CSS, the HTML, and JavaScript that does whatever it is you want to do with the DOM. For ML, it does not just work like that. You really don't have to write the code for the actions you want. Like, you just build the model, and the model is there, and you just give it the inputs, and it just works. It's a bit difficult to explain if you are stuck with the perspective of actual coding. Like, I'm building an endpoint, and this endpoint can take in these arguments, or you are building a mobile application. This mobile application can do X, and you know exactly how all the if statements in it work and all the else statements in it work. But for machine learning systems, it's just difficult, but it works, which is kind of something I think software engineers not really like, that discomfort of not really understanding what exactly is going on. While it works, and that is a good thing, which is a blessing, it also means it is hard to make specific changes. So let's say you give it a model, you give your model a text, and the text is, say, the Nigerian national anthem, and it fails to summarize the Nigerian national anthem. You really can't say, okay, it failed because of the word Nigeria in it, and then say, if this model says the word Nigeria, let it work well. You really cannot just go into your model and be like, if it says Nigeria, do this. That's just going to be writing explicit code, which is what we are all used to. But you really cannot do that with your models because it's doesn't need explicit logic. Then it takes in a wide range of inputs. So if you have your model once again, and it's supposed to say, well, is this image an hot dog or not hot dog? For those who get the Silicon Valley reference, you can expect it to get lots of inputs, and you really do not need to say, oh, what happens if there's a certain edge case? Or what happens if there is a -1 error? If there is a one-off error here? What happens if I'm missing this particular iteration on the for loop? You don't have to deal with that. It just tackles a wide range of inputs. Because it deals with variety well, it also means that if you have lots of inputs, say tens of thousands, it is hard to say specifically which of these inputs are failing, or hard to say why those inputs are failing, because it is what it is. Like, it's just part of its nature. Then it's a black box. Now, by black box is just a jargon you'd often get to hear in the machine learning ecosystem, which can just refer to the fact that, as I said earlier, it just works. So you just give it your input and you expect to get output. As a result of that, it's just working, it's able to find lots of patterns through the various layers that make up the neural network. So say a neural network can have 100 layers. Don't take my example so seriously. It has 100 layers. And then as a result of those layers, it's able to find patterns at different levels of granularity, which makes sense. It helps us because it works. It finds patterns that we really can't see as humans. But then, while it works, because it's a black box, it's hard to explain what the patterns are. For example, if Netflix tries to recommend a movie for you, and then it explains to you why it's recommending this movie, then chances are you'd probably want to trust it a bit more because it's saying why you watched it, why it's recommending it. Say it's recommending Mission Impossible because you say it's recommending Mission Impossible because you watched Avengers some while ago. Like, I don't know why to say that, but it says that. But the fact that it says it makes you have much more trust in how in the predictions that the model gives you. So it's more like that dichotomy of it being a blessing and a curse. So now that we have accepted that this is the case, and not to say that it is actually impossible to figure out these things, understand how the black box works, but it is ongoing research, and these things can change very quickly. Good. Now that we've seen that, some sample use cases of machine learning systems include self-driving cars. You see ML systems being used there. For example, in a self-driving car, some things you'd expect, which are the ML components, could include the object detection models or models for predicting the bends in the road based on whatever map it's using. For document editors, if you've used Grammarly before or Google Docs, then you've probably seen predictions there. For system software, this is a bit much more nuanced, but there are certain system softwares, say, for example, operating systems, or even embedded systems, where there are very tiny little machine learning predictions going on here and there. For example, if you have the home lighting system, and then it's, say, based on the current weather, it tries to predict what the lighting would be, if it's going to be like a dark day or it's going to be a bright day. On a rainy day, if it predicts it's going to be dark, then it could possibly say, okay, then the lights should go on. If it's going to be a bright day, then the lights should go off. Things like that. It's a bit much more nuanced, but I do hope you get the point for the sample use cases. Now let's proceed. Interacting with ML systems, there are about different ways you can go about doing this. But if you are to look at it based on existing systems, there are these 4 ways that makes it easier to manage the system's failures as well as manage the user expectations. So automate, prompt, annotate, organize. I hope they are not big words, but I'll just go into it. Once again, automate, prompt, annotate, and organize. So what do I mean by automate? This basically refers to taking an action for the user without giving the user the ability to approve or decline. Say in a situation where it's a self-driving car, and based on the computer vision model, in this self-driving car, it says that the road is clear, it's free, it's straight up. And then you decide to have a model that automates this bit of making the car speed up. Now, in this case, the user does not have to approve or decline if the method of implementing this ML system is to automate its prediction. So it predicts that, okay, you can go faster, and it goes faster. You don't have to say, oh, stop, or you don't have to say proceed, or you don't have to say, go at this certain speed. Automate just does it, and you don't have to do anything else, which kind of sounds good. I think it's the kind of thing you get to see in the movies. This robot comes and just does it, and it's like, oh wow, nice. But that doesn't really help us much, because in reality, machine learning systems are not always that good. As I said earlier, imagine the ML system is 95% accurate. Using the self-driving car as an example, for a model that's 95% accurate based on what it sees on the road, so it works 95% well, and then it speeds up. Oh, that's nice and good. But what happens to the 5% where it gets it wrong? Do people die as a result of wanting to get the feel of automation? How do you get to fix those cases? Hence, automation actually needs to be really good for you to use it. And the intelligence needs to be really good for you to use automation in this case. Also, the mistakes, the cost of making mistakes there needs to be low. So if it's automation of of say something like a document editor now, and then say you're using Grammarly and you type something which is an obvious grammatical error, and Grammarly does not ask you if you want to change it or you don't want to change it. Say you type something like METR, and you just put a space if you intend to type meter, for example, and Grammarly just changes it for you. It does not ask you. If it gets it wrong, then you're not going to die, right? I mean, you could be frustrated a little bit if it gets it wrong, but you're not going to die. Nobody is going to lose money for doing that. Well, I guess it depends. There's probably going to be much more context to that, but I hope you get the point. So for automating, it's basically taking the action on behalf of the user without giving explicit abilities to approve or decline. So that's one way to integrate your ML system into, say, the entire software, or hardware system, if that's what you're using it with. Then the other one is prompting. Now, what prompting basically refers to is enforcing an interaction between the user and the system. So let's say if you are trying to use your banking application, and your banking application is asking you to prove that it is you, for example, let's say it's trying to do this with your camera and then it's face recognition. In this case, you could basically just have it automate how it registers that you're the one, and it just goes in. But in that case, because let's say you are not doing software-driven development and you have lots of money, like I'm not very sure all of us would be quite confident to have only the facial recognition as the security layer for our banking apps. You probably would have something that's much more concrete, like a prompt, say, put in your fingerprints, for example. That's a trivial example here. But you have other cases where, if using the self-driving car situation as well, say it sees that the road is free and it asks, can I speed up? And it does not speed up and it does not slow down, it just continues going and takes no action until you either accept or you decline. So that's prompting. Now, in this case, the intelligence does not have to be very reliable, because it's fine for it to be wrong at some points. And when it is wrong, you are comfortable with the fact that it's just the user now. Like, the user can easily tell if this situation is the wrong time to use it, and you click the no prompt. And if you want to click the yes prompt, and that works. Like, as you can see, it gives room for failure, because the model is not just doing things on its own, and it's giving the user much more privileges to have an impact on whatever it is it decides to do or not. So that's it for prompting. So for example here, this is just like a random example where you have with Grammarly, where Grammarly I don't think Grammarly automatically does an automation action. It just prompts you for most of the time. So here it's like prompting, where there has been many opinions about cloning over the years, and then it prompts that there is a better option of using ARV. So that's one way to go about it. And Grammarly could very easily just decide to go the automation route and just do it right away. But you would easily see that this kind of can become quite frustrating. While it sounds like prompting is nice and good, it feels like a silver bullet, right? But it's not so good for the users either way, because imagine you're using an application now. For me, I don't know if this is same for you, but just let me know in the chat if it's same for you. The moment I get to see a lot of prompts for a certain application on my phone, if the prompts becomes more than 2 or 3 a day, then I just forget about it. I don't even respond to them anymore, because like the prompting becomes too much, and I start to get tired. Like, there's this concept of prompting fatigue. Like, you ask the user too many questions and they're like, what's even the point of having the ML in the first place when it's asking me everything? So there's that. While prompting sounds all nice and good, it can potentially decrease the user experience for everyone. So that is for prompting. Then there's annotating. Annotating is much more subtle than prompting, in the sense that it just puts in the information there. Say using system software like your operating system as an example, if your battery is low, it kind of just annotates it somewhere and says the battery is low. You should try to charge soon. Or even as it is with some certain applications, I think MS Word does this, where if you get something wrong, it kind of just has this red bar under it, which is basically an annotation. It does not ask you to do anything, just points you towards it, and then you have to go there for yourself to read and see what's going on. It's very passive, and it actually needs you to take your action manually. Um, this is good for the users sometimes, uh, but for the large part, it's probably bad for the entire ML system. Why? Because the user could potentially miss those annotations. And at that point, because ML systems are expected to get better over time, and the only way it can get better over time is through feedback. So if you don't give it sufficient feedback, you really cannot see something to build on. And the ripple effect of the users not taking action and forgetting the annotations is that the system does not see what to build on. So it kind of rolls back from not doing anything from the user to the ML model having nothing to work on. However, annotation is still a good way to go if the model is not very trustworthy. So it makes mistakes a lot, and things of that sort. If it fails, like all fine and good. But if the users actually really need to use the ML system, then they will pay more attention to the annotations. But for those who do not really care much about it, they could just let it go. So say this is some form of an annotation on a vehicle dashboard where you have the um the seatbelt sign here. Basically, it's an annotation approach where if you don't put in the seatbelt, it lights up. Now, it's left to you to decide to do something about it or not. It does not force you to be like, oh, this car is never going to move if that light does not go off. So it's not actually a prompting action. It's just there. Do something if you want about it. Do something about it if you want or not. So that's it with annotating. Then organizing basically is a much more specialized way of having your ML systems having users interact with the ML systems, because it only makes sense if you have lots of information. So imagine you have 3,000 documents and then you want to read all of them. Then do you actually need to start from the first and go to the end? In this case, you probably would want to organize based on your interests. Oh, I want to read the articles about how Chelsea has been performing terribly this season. Then, in that case, you could now organize your articles and sort based on how well they relate to that topic of Chelsea performing terribly. Like, there should be lots of articles on that, obviously. But this interaction does not necessarily have the users do something. It's just there. It reduces the mental workload for them because they don't have to read everything and then they know where to pay much more attention towards. So that's like the four main ones. There you could have like hybrid systems. So it's very possible to mix and match things. So you can have a system that automates as well as prompts and annotates. Say, for example, you have an operating system that when certain resources are being used more, it can predict that certain applications should be closed off. Like that is automating, but it could also annotate at the same time, telling you that a certain action has been done, but you can decide to pay attention to it or not. But it has taken the action it wants. It's now left to you to just be aware that okay, this has happened, and then you understand what exactly has happened. So it's not a case of one has to be used without the other. It's you could actually very well combine all of them. So this is just YouTube. If you are to finish all of YouTube's videos in a lifetime, I actually think that's absolutely impossible. But because YouTube kind of recommends what it feels you would need more, it organizes it into a certain kind of formats or order that would be most beneficial for you. So once again, interacting with ML systems, you can automate, you can prompt, you can annotate, and you can organize. Does anyone have any questions before I proceed? Okay. Long awkward silence. I think that means say no. Then the next one, accepting the perfect imperfections. So now that we've seen that ML systems are actually never going to be perfect and you have accepted that this is the case, what do we do about it? You can either decide to put in guardrails, you can use the age-old undo button, which I know everybody knows it, right? But when you're very engrossed in the old ML thing and you're quite proud of your work, then it takes quite some discipline to decide to put in an undo button that undoes whatever it is your model is trying to do. Then the human in the loop. You can't hear me well. Is this the same with everybody? I think someone says they can't hear me well.
I can hear you clearly.
Okay. Okay.
Can hear you
I
clearly.
think it's probably from your end, Abdulrahim. Okay, thank you. So next, let's go into guardrails. So what are guardrails? They're basically just mechanisms to check that the results of machine learning models make sense. And the guardrails can either be machine learning driven or just plain logic based on proxies. What do I mean that? What do I mean by checking if the machine learning models make sense? Say, for example, you have this ML model once again that says like the road is all clear, you can keep going right away. If you rely on just that model, it could be like the right prediction based on that single task of is the road clear or not. But if you have a guardrail, for example, something like is it going to rain, or is there a child close by, or is there a school close by, or what's the tendency that there's going to be a curve right ahead? You could have these machine learning models which would support the actual actioning model. So while the model says the road is clear, all fair and good, keep going, you have these other machine learning models that can test or can make predictions for other things to see if the actual model itself is doing something that makes sense. So if the model says all clear and good, but there's a second model that's predicting the road is going to be slippery, or school children are going to be going out of school pretty soon, then that's going to be like a guardrail for the actual model and saying, yes, you're right, but this guardrail say does not really make sense for you to do that. And you can decide to just cut short the action of the machine learning model at that point. Now that's making use of a machine learning model, another machine learning model to do this. It's also possible to train two machine learning models based on that first action. So it could be ML models of different types. If the first one, just as a very trivial example, if the first one is like a transformer-based model, and the second one is just a naive-based model, where the first one does the actual prediction, but the second one kind of checks the first one. Now, this is a bit tricky because if you could easily tell that the prediction of the model is right or not, then the model is not needed, right? But the point of this model is just to be like a double check, so like a two-step process, because some models, some outputs would be wrong that the second model can potentially detect or predict that they are wrong, and you could potentially nip those mistakes in the bud without having them just leak out that way. And now you could have plain logic based on proxies. So by proxies, I mean um, making use of other signals on the system. Say, for example, if you have um, a a document editor, and regularly, normally you have your Grammarly, for example, works well with English, and the language in this case is set to Yoruba. But because Grammarly does not necessarily have, say, Yoruba models, in this case, this is just going to be a simple if else statement of if it's going to be Yoruba based text, then don't even bother about making any predictions. Like it's just basic things. Like if it makes logical sense for you to make this prediction, then go ahead. Otherwise, don't go ahead. Like you don't even need to make predictions at all. It's just plain logic. Don't need to do anything about those. So those are basically guardrails. Using those to ensure the machine learning model makes predictions that make sense, or are making predictions in cases where they even should be making predictions at all. So that's it about guardrails. Then the undo button. Now the undo button is like plain simple. I don't think that needs a lot of explanation. Uh, but then the undo button could be risky or could be plain useless if you are using automation. Now imagine a case where you are automating, yeah, you have a model and then you have an automating integration style, say a model that makes predictions about stock, and then you automated it to yes, you automated it to undo, you automated it to make to purchase stocks. Like you really cannot undo that action. Like you're supposed to, like, it's gone, like gone. There's nothing you can do about it. So in that case, the undo button is plain useless. But for certain cases, you can actually undo them. And then the Control Z works. Say you have a lighting system and it's for some reason it says the lights should go off. Like the undo button in this case, you just be turning the lights on. Or you have Grammarly where you accepted a recommendation. You could easily just say no, I don't want it again, and it undoes it. Or you have YouTube where YouTube predicts something. You could easily say, no, I don't want it to predict or organize my YouTube in this way. You could very well just determine how you want it to go. So that's the plain old undo button. Then you have human in the loop. So the whole concept of human in the loop is having the whole concept of having human in the loop is when your model gets your predictions, but before the actual users see it, you have someone who stays in between who could potentially say, oh, if the model predicts that it is 50% accurate or 50% sure of its predictions, then we can let it go. If predictions are less than 40% or 55% or whatever, then you have someone who is going to take a look at those results. Yeah. Now, for context, a certain situation for this would be something I worked on sometime last year, where you could try to extract certain entities from documents. So you want to extract things like who employed who in this company, who said what in that company, and this kind of things are supposed to be put into a final report that goes to like the CEO, for example. Now the CEO is the end user, right? The CEO is the final use case of the extracted entities. By entities, yeah, I mean humans, locations, yeah, I think that's mainly it. Humans, locations, organizations. But you have someone who stays in the loop and it's like, oh, this result here, the model says it's not that confident. So let me take a look at what the data is like. Is this actually correct? Is it supposed to be much more confident than it is? Now, it's not say that the confidence score of models are always right. Like we've seen cases where the model is very confident and it's basically plain jargon. Like we have ChatGPT there, which can confidently say rubbish. So that's like signs that models can actually be confident about something, but get it explicitly wrong. So the human in the loop just kind of stays there in between the model's outputs and what the final use case of the output would be. And then they just stay there. They push whatever the model gets explicitly wrong or do not make sense. They just have that in like a feature store or a document store, and the ML guys can get to work on those later. So those are like three ways to go about accepting the fact that ML systems would make mistakes. And in lots of cases, like it kind of works to just do that, to just do any of those. because you could even decide to not do any of those, to be honest. It depends on what risk is involved in your application. For example, if the model is something that generates questions, like if it generates a long question, nobody's going to die. Like you don't have to put somebody in the loop to say, is it right or wrong? Mbaraki, you can ask a question, please.
Yes, I'm particularly interested in the undo. So,
Okay.
so what happens when, for example, um, on YouTube you say don't recommend this video.
Mm-hmm.
For me, my intuition is it does not retrain the model. So how does that how does it remove that item from the node or from the knowledge graph so that it doesn't recommend to the user anymore? Yeah.
Okay, so first disclaimer is I don't work at YouTube, so it's hard to say how exactly things are working in the background. But my intuition would be that these videos would potentially have features. So basically, what a feature is a feature describes what an object is. So let's say for your videos, you could have like a long vector, like just a feature that says, oh, this video does has this attributes, has that attributes, has 512 attributes. You could have each feature like that assigned to the vectors. So one way to go about this would be that whenever the model is making recommendations, it's basically blacklists or says any other model that has similarities with any other video rather than has similarities with this particular video X person has blocked, then don't continue recommending. So that could be like a guardrail as said earlier. So that's like going to be a combination of where you've done the undo initially, and then somewhere else in the pipeline, you have like a guardrail that says, okay, the model is predicting this video, right, which is correct. But because there's this guardrail that says check similarities between certain features, then don't predict anymore. That's one way to go about it. And yes, as you said, they're definitely not going to be training the model immediately you press the undo button, because the process of training is very intensive. So that's one way. And then doing similarity checks is like a very it's compared to doing an if statement, it's compute intensive, but compared to doing the training itself, like it's a very simple thing to do. So that's one way they could potentially go about it. Then another way could be just checking. I think there's another option on YouTube where you can decide not to recommend this channel at all. So that one is even much more straightforward. Like that's a plain if statement, if that makes sense.
Yeah, yeah. So sorry, I didn't catch the last part. You said what that is a what statement?
Like if you just ask it to not
Not
recommend this
recommended
channel
the channel.
anymore, like you
Yes.
can basically just exclude that channel's title or that channel's ID, right? Like that's
Hmm.
just like a simple SQL statement, if it makes sense.
I see. For that user's
Account
um
only.
I see.
Yeah.
Huh. I see. Thank you.
Okay. Thank you for the question. So the next thing will be going into feedback. So feedback is actually quite important. As I said earlier, um, I think this is even very clear for everyone to see. ChatGPT was probably released on sometime in December, and the quality of its predictions now, up until now, has improved a lot. Maybe it's just me. Maybe it's actually the case, but I think everybody would probably have observed that. So how is this going on? It's basically feedback. Feedback can easily be explicit or implicit. So by explicit feedback, the user can say that this prediction is correct or wrong, and it works easily with prompting actions or annotations. So using ChatGPT one more time, I think I've nearly watched that example, and it's almost right. But on ChatGPT, you'd probably see the thumbs up and the thumbs down button when it sends you something that you think is wrong. You could thumbs down. When it sends you something that you think is correct, you could thumbs up. Those things are not just there for fancy. They're actually taking note of those things, And it does not mean that the moment it thumbs down something that they accept that it is wrong or it is right. Like they just agree with you, and it means it's going to be reviewed, or they could take further steps when training the next model. Besides that, it's very valuable information. And this is the same with other kinds of models as well. When you use Grammarly and then Grammarly suggests something to you, while you can tell Grammarly to not take that action, you could potentially go a bit further and say this prediction is wrong. That is explicit feedback, and it makes use of that feedback to train future models. So you could say predictions are right or wrong, and the models get to build based on that. Now, there's probably this, people probably think that when they send out feedback, that it means the next time they use it, it gets better. No, it's just a thing of during the next iteration, then, or after a review, then the model is likely going to make use of that feedback to improve. Now, the main reason why it works well with prompting and annotation is that when you prompt, you are basically blocking the application from going further. So the user actually needs to do something or not do something. Like it's blocked there, meaning the user is forced to give that feedback. While for annotation, the user sees it, and then they could easily decide to now act, or say they've seen the annotation, they could now decide to act based on the information you've given them. And that could be considered explicit feedback as well. But the issue with explicit feedback is, as I said earlier, it could be tiring, and sometimes it's hard to say for sure if the user actually really means it. So if for prompting now, the user does not respond, like that's no feedback. But you have to read something into it. It could either mean the user got tired. It could either mean the user was in a position or in a certain situation where they were not comfortable giving that response. It could either mean they just got frustrated with the entire thing. But most times when they decide to click the button, it could very well just be, okay, this is what they genuinely think. And then there are like people who have bad intentions, where they just try to say it is correct or it is wrong, when in that actual case, the model is actually wrong. Like these are some things you have to dance around. It's just part of the dance to get feedback from the users and then make use of that in your model. Then there's the part of explicit, where the system tries to assume what the users think of the model. It works well with organization and automation. So using Google, for example, I don't know if everybody knows this, but when you Google search something, Google, this is something that has been known. I don't know if they still do it, but they track scrolls, they track the links you click on. So if you click on the very first link and everybody else clicks on that very first link, they're tracking those things explicitly. And then they can very well say that because everybody is clicking on exactly this first link, it is the most relevant for this query. Now, you are not telling them that this is valuable or not, but they are implicitly saying based on your actions that this is the case. Now, if the first article is not useful, then you click on the second. That's implicit action that the first article was not useful enough. Then now they're like, could it be that the second article was useful? So after the second article, you don't go and click the third one or the fourth one. Then that's potential signal of what's going on with their results there. But there's an issue with implicit feedback as well, in the sense that it is hard to tell if the prediction is actually right. Say, for example, you have with organization, you open your YouTube page, and YouTube has all of these videos for you to watch, and you end up clicking nothing. Like, what does YouTube think? Should they think you did not like any of the videos? Should they think, okay, you probably did not even use the application at all? Should they think that when you clicked the video at the bottom, that all the videos at the top were completely useless? Like, while they are taking implicit feedback based on the actions, they also need to be wary of what could potentially be third-party factors that could basically just mean that you are taking this action, or this action you are taking that is not explicit to them could be as a result of something else. Say, it could be like various things, to be honest. Say, for example, using like the lighting system. I'm just trying to give as many examples as possible. So it's kind of clear in our mind. If the lighting system turns off the light at the right time or at the wrong time, more like, and you are trying to get feedback, but the user is not like the user has decided, even the fact that it is wrong, the user decided not to turn on the lights back after the system has turned it off. You could decide to say that okay, implicitly that means it is right, but it could be very well be wrong, and the user is just the line on it and be like, what's wrong with this thing, Seth? And but what do you decide to do from that? Like the user has not explicitly done something, but you still need to make an assumption there. So those are like some ways in which systems get to take feedback. I think even Google, as an example, has a button to explicitly say if results are valuable or not. So I really can't say for sure, but I've probably seen that somewhere on the search engine. So that's about it for the lecture. Once again, to just go back, I talked mainly about how to interact with the systems, which is automating, prompting, annotating, and organizing, where automating just means taking the action without having the users do something, while prompting would be stopping everything for the users to take an action before the system goes ahead, while annotating would be having a very passive information that lets the user know what is going on. And organizing would be in cases where you have lots of information and you need to get the most useful ones to users first. So you organize based on what you guess the user interests are. Now that one is actually quite interesting because knowing user intent on its own is a very difficult problem. Like people go to do PhDs for 4 years just trying to know how do you decide what the user's intent is just based on their queries. Like this, when you go quite deep into them, this four could potentially become rabbit holes to look into. Then I looked at accepting the perfect imperfections using guardrails, where the guardrails could be using external or other machine learning models to fact check that the first machine learning model is correct, or it could just be using proxies, like using signals, say time of the day, depending on what the application is, or what the user is currently doing. Just plain if and else statements to check those things. While the undo button kind of reverses the action the model does, but that's not always useful in all cases. Then you have human in the loop, where the human comes in and checks the results to see that everything is correct. Then I looked at the feedback methods, which could be explicit or implicit, where by explicit I mean the application or the product as action items where the user can be like, oh, this is good, or this is wrong, or they can type in a comment and be like, this is wrong because XYZ, this is good because XYZ. That's like explicit. It's the best, but I mean, like, how many of us even get to use any of those? Like, I've been using ChatGPT and I only remember ever clicking the button once and just a thumbs down button. I don't know if that means anything, but that's then why, because explicit is not something people will get used often. Like the companies cannot just fold their hands and wait, right? They need to provide the best value to the user. So they often have to rely on implicit feedback where they track lots of user actions, like any application you're using or standard applications you're using, like, and you have ML systems that it's very likely that they're tracking almost everything you're doing. We've probably seen documentaries on things like this. They don't really know it is you, yeah, because they're like things that wipe off your personally identifiable information. So nobody can really say, okay, it is this person with this email that's doing XYZ. So it just looks like a random user because of data constraints, data privacy constraints. So they have the privacy thing wiped off. So the part of they know it is you, and then they want you to watch this video more. I don't think that's valid. However, they are still tracking your activities, and then they can, based on that, try to give you the things that would be much more valuable to you, or in some cases, give you the adverts that be much more valuable to you. So that's about it. If there are any questions, I think now would be a good time.
All right. Someone has a question
Okay.
in the Q&A section. Person says, are there algorithms which ML models use to achieve high accuracy despite adversarial feedback, or is all feedback manually reviewed? You can check
Okay,
the
let me.
QA.
Yeah,
I'll
I'm
copy and
checking.
paste in the chat section.
Are there algorithms which ML models use to achieve high accuracy despite adversarial feedback, or is all feedback manually reviewed? So, uh, my answer to this would be because all models are supposed to make predictions. There is actually no model that could actually say for sure that there's that could that this prediction is quite correct for sure. That's 100% reliable, because if you have the answers, then you don't even need the model in the first place. Like, it's a very tricky question because you want the model to be correct. You want to know that the model is correct. But if you can say for sure that the model is correct, then you really do not need the model in the first place, if that makes any sense. So now to move to the part of this, all feedback manually reviewed. My answer to that would be no, because it is humanly impossible to manually review all feedback. But potential ways to go about this would be to check for bias or differences in various feedback gotten. So if you have feedback that comes in, if it's a binary feedback, for example, and you have the feedback coming from lots of people, say it comes from 10,000 people, and 8,000 people say that this is wrong, then you could potentially say with certain confidence that because 8,000 people say it is wrong, then you could decide to go with the majority and make that change based on what the majority have said without explicitly going through what each one of them have said. Now you could also have models if it's one where the user puts in the comments. There could You could have models that are trained to extract signals from the text, because nobody's going to be reading the text themselves except it's like cases where it's absolutely needed. You could have models that look into the feedback, but you really can't say for sure that even those models are correct. So it's once again, so it's all part of the dance, trying to optimize as much as possible. But there's also the trade-off of the more models you have, the more compute you need to do, the more money you have to spend. So it's in between how much compute do you want to do and how much of it would actually even be valuable, because there are certain applications where going from 90% accuracy to 95% accuracy would not make the company much money. So in that case, you'd be like, what's the point? If that makes any sense. So I don't have any concrete answer except just providing context that yes, there are models you could use to check adversarial feedback, but you can't say for sure if they're going to be highly accurate because they are models themselves. Like, and then is all feedback manually reviewed? No, because it's humanly impossible to do that. So there has to be ways to, or there are ways to also like check. Firstly, if the feedback based on everyone is tilting more towards a certain direction, or if certain things stand out more from the feedback gotten. Yeah, Maya, I can ask a question.
Yes, sorry. I just want to like pick your brains here. So,
Okay.
the Tesla, what do they even call it? AID, for the autopilot. So they mentioned that so if the model makes a mistake, right? They
Mm-hmm.
try to recreate that the exact situation on like simulation, like under which aspect does it fall into in all the things you've like explained to us. So such scenario, whereby they try to
Okay.
recreate everything, the environment and the scenario, the position of the cars around and everything.
Yeah, so I think that could potentially be implicit feedback in certain ways, because now nobody's saying anything about what exactly went on, but because they have like signals or sensors they are using to track what the situation was like at that point, they could use that to recreate. So if I'm to answer that question, I think it potentially falls under getting implicit feedback, because it does not fall under the other ones, which is because this is something being done after the fact that something has like that the vehicle has had the issue. So it's comes under how they get to store the feedback, what sensors are being used to try to recreate that scenario. If there's someone who could come and say exactly what went on, if there's a video, for example, then that could be much more explicit. But if it is making use of sensors to recreate the scenarios, then that's much more implicit than having a video that gives you what exactly went on, if that makes any sense.
Oh yes, yes, it does. Thank you so much.
Okay. Yeah, any other questions? Okay. It's like that's long, awkward silence.
All right.
So that's going to be, thank you. There will be a session after this, which should go a bit much more in depth with the concept. Now we are going from what happens at Inference to what could potentially be done while training the model to avoid the mistakes, which is you probably would need some exposure to what goes on during model training. But I think anyone who is just excited about the concept could benefit from that as well. But that's what the next session would be. I'm not very sure when that will be, but it could be next weekend. I think Deji would keep everyone in touch with that. Yeah.
All right. Thank you very much, Habib. It was a nice session. I think I learned a lot about implementing ML systems. Given that I'm going to be making use of a model like ChatGPT and what I'm building, it has been really helpful. I didn't know much about annotations and the prompting thing. I mean, I've seen them in action, but I've not really seen practical. I've not really seen. I didn't really know that they actually terminologies for these things. Thank you very much. And thank those who had questions. The more questions you ask, there are some of us that we don't know what to ask. Some of these topics are new, some of these concepts are new. We are so overwhelmed that we don't have questions to ask. So it's quite good when others ask questions. Um, so yeah, in the absence of any questions so far, as Habib mentioned, it's actually a series, and this is the first in the series. We'll be having two more sessions concerning this topic. And as you can see, we have ML Systems for Part 2, and that'll be how to manage mistakes from model training. Now, a very good use case for those who may be thinking, where am I going to use ML? In the past few weeks actually, not even months, few weeks, we've had lots and lots of products that have been built making use of machine learning. Specifically, I know Match Day. If you are conversant with Match Day, it's like a platform very similar to Football Manager, where you select your player, select the formation, and your players are simulated against another player's team, another person's team. And the commentators, like the summary of the match, is actually done with Chat GPT. So it gives more or less like a human friendly response. Lots of products have been built with AI, and I'm very sure lots of people here will be building products also with AI. If you are looking to build something for a portfolio, something for a CV to show recruiters, it's a very good opportunity. So I would encourage you guys to attend next week, which is going to be our next session. I mean, it's every week on Sunday. So you can learn more. Bello, you have something to say. Can you speak up?
Yes, sorry, it's just like a contribution. Like I think we as a community, our small community, we should have like open source. I'm just saying like if we can have like open source projects that we can contribute in, I think that will help a lot. Because for me, I really would love to go fully into like artificial intelligence and machine learning, but I can't just go into it. So I feel something like an open source would just give me that how do I put it, like a bit by bit transitioning.
Okay. All right. Well, I would look into that. In the meantime, you can send me a message directly. I'll give you a link to data science machine learning community if you need to join the
Okay.
community. And that goes to anyone who's interested in joining the community. In the meantime, if you want to join any community, you can just send me a message. I'll send you a link. I'm in lots of communities. So I think that's what I can say in that respect. So yeah, coming next week, in case you have something you use with AI, and you want to ask a question about it, I would love to hear about it next week. I don't have enrichment though. All right, guys. Thank you very much for showing up. Thanks, Habib, for the session. it was a very wonderful and enlightening one. And lastly, last request I'll make for you guys, to everyone, there is a poll in the activity section on your Google Meet application. If you're on mobile app, just go to the activity section. If you are on laptop, you can just check bottom right corner, the second to the last icon. Click on it and please vote the poll. I'd like to know what area of specialization of tech is that attending today's meeting, so we can share it up towards future meetings. All right. Please vote before you leave. Oh. Thanks everyone for showing up. I'll be uploading this recording to YouTube. It's actually very hard to compile, and that's why you see I tend not to upload it immediately because I want to fine tune it. But yeah, God helping me and giving me strength, I would edit this one and upload to YouTube, and I'll let you guys get the recording. All right then. Eat well, sleep well, have a nice night. Bye.